Welcome back, Pre-Cal Compression. We are picking back up into the second part of our polar intro lesson. We just finished example 2, but let's generalize. We found 3 different ways we could represent the same point. That's very important for you to understand. Even though example 2, it looks very, very different, they'd all be exactly the same point location. So generalizing, if you have a point r comma theta, you can represent that as r comma theta plus or minus 2 pi. You can see that's what we did here. We had a pi over 4. We subtracted 2 pi in essence. We could, in this case, get a negative 7 pi over 4. We even could have added a 2 pi and gotten something coterminal. We would have gotten 9 pi over 4. That would work. But with the negatives, my goodness, very, very, very important. We're going to go to the opposite quadrant, and that's going to be 180 degrees away. So we could either add or subtract pi. And you can see what's happening. That negative r indicates that we are projecting backwards from that opposite quadrant. So you could see when we had a start with pi over 4, of course, we could add a pi to that. That's how we had a 5 pi over 4. Or we could just as well have taken a pi over 4 minus pi. So let's generalize. Let's just say that you've got this point, r comma theta. By the way, you could think of it as x comma y also. What if I gave you r comma theta? Could we find x and y? Well, undoubtedly, the most famous theorem in mathematics is the Pythagorean theorem, and you will use that a lot. X squared plus y squared equals r squared in this case. We also have SOHCAHTOA, and you could see from that, you learned this last year, this would be opposite, this would be adjacent, this would be your hypotenuse in relation to theta. Sine of theta would be y over r. My goodness, that's our coordinate definition that we learned earlier. Cosine of theta would be x over r. That's also our coordinate definition. And finally, tangent, opposite over adjacent, well, that's y all over x. All of these could be thought of as coordinate definitions that we've been using all along. Well, here's really what's happening. If you start with r theta, could we find the rectangular, also known as Cartesian, x comma y's? Yes. What can we use? X squared plus y squared equals r squared is a possibility. Solve for x. Look at this. If we multiply both sides, this one is actually the big one we're going to use. X equals r cosine of theta, and our y is going to be r sine of theta. In all truth, we're going to be using these predominantly. But of course, we also have, the tangent of theta is equal to y over x. You'd always, have that at your disposal as well. But these are the ones, my goodness, let's do 2 of them real fast. You can see that here is your r, here is your theta. And you could say, well, could I find my x and y? Could I get the x comma y coordinates? Well, x is r cosine theta. Y is r sine of theta. And I will just have to work this out. By the way, you could do this very fast now. You could also very quickly say, well, gosh, where is pi over 6? It's down here. And, cosine is the x. The x is big in a 30, 60, 90. So that's your root 3 over 2. Y is the sine value on a unit circle. So you could see this y value on the unit circle is small. That's 1/2. So the 2 would go into the 6. You'd get a 3. We'd have 3 root 3. Here, half of 6 is a 3. So you'd say, well, here is my polar form. What would we have seen in Cartesian rectangular x comma y's? It would be equivalent to this. Okay? I want to tell you too, this is very important. You could, thankfully, even when you have a negative r, these formulas are still going to work. Look at this. This is lovely. You're going to have negative 3 times the cosine of pi. You're going to have negative 3 times the sine of pi. And you just have to work that out. Okay? So if we were to look at pi real quickly on the unit circle, pi is right over here. And that's the extreme point, negative 1 comma 0. So cosine is that x coordinate on the unit circle. So we'd get negative 3 times negative 1. And look at your y coordinate on the unit circle here. That's 0. Negative 3 times 0 is 0. So wow, that's 3 comma 0. Now, I do want to point something out here. This is really cool. If you know how polar coordinates work, you could actually have done this lightning fast, because you'd say, where is this point going? You'd say, go to pi. You'd say, well, pi is right over here. Project it backwards. And, going backwards, you're going to go to the positive x-axis. And you'd go 1, 2, 3 steps to the right, shooting at that direction. You could just figure out that you were at 3 comma 0 without any calculations. Because for that angle, down at 0, that's going to correspond exactly to your x comma y. Well, let's flip over to our last page. It says sketch a point and then mark it. Tell you what, I want us to actually skip that first example and to do this one. And see, we're going to go from rectangular. See, this right here is your x and your y. And they want us to find r comma theta. See, now we're going to go backwards. So you'll think, wow, okay. From what we were doing before, that is, in the reverse. So look, x equals negative 3. I've got this right here. I've got y equals negative 3. That's down here. That's my point. Right? No doubt about it. We could plot that. We've been plotting that for years. Left 3, down 3, put your dot right there. But they're saying, could you find an r comma theta? Well, if you look in that box that we had on the previous page, there were 2 other formulas that we didn't use so much. When we're going between the 2 systems, we can just as well say, hey, you know what? We also have the Pythagorean theorem. We're also going to have this guy that we haven't used. We're going to come back to him in just a minute. But take a look at this. This hopefully won't take you too long. We're going to say, hey, negative 3 squared plus negative 3 squared equals r squared. So I've got 9 plus 9, which is 18. R is always positive, by the way. So I've got radical 18. And this is 9 times 2. And the square root of 9 is 3. So that's going to be 3 radical 2. Now for future reference, you're hopefully going to remember the special right triangle where you've got half of a square. You've got you've got A radical 2. By the way, that's a 45, 45, 90 right triangle. You might remember that from Math 3. Well, we found our R. Guess what? We've got to find our angle. And to find our angle, we could say, well, the tangent of theta is y over x. And tangent of theta is going to be y is -3, or x is -3. You could say, wow, the tangent of theta is equal to 1. Now, it's very, very, very easy to say, ooh, I've got pi over 4. I think we have seen over and over and over again that we could have an angle of pi over 4 and then tangent equals 1. However, please understand, pi over 4 is in the first quadrant. And guys, this angle is in the third. So you know what you just found? There is a pi over 4, but that pi over 4, guys, is in that reference angle. That is the angle inside the triangle. So we're going to look at that and say, okay, well, how do we fix that? Well, real quickly, we make that quadrant adjustment. We'd say, well, it's pi over 4 past pi, and that's 5 pi over 4. So if you wanted one singular answer here, just one R and one angle, there you have it. Obviously, we could extend, as we've done before in a previous example, we could ask for 3 other polar coordinates, one where R is positive and an angle is negative. You know, you could have like 3 root 2 and then negative 3 pi over 4, right? It's actually, you know, what you'd come up with if you'd subtract, you know, that out. That is subtracting 5 pi over 4 minus 2 pi, or you could just deal with the negative direction here. Could also have gone to the opposite quadrant. But let's summarize as we're going rectangular to polar. To find R, use Pythagorean triples or the Pythagorean theorem. Okay? If points lie on the x or y axis, or axes, I should say, use quadrantal angles. You know, angles like pi over 2 or pi, 3 pi over 2, you get the idea. But in general, to find theta, use the tangent of theta equals y over x. Be careful, we just saw a minute ago what could happen. The angle may be the reference angle and that's inside the triangle. And that means you are needing a quadrant adjustment like we just did a minute ago, getting to 5 pi over 4. And of course, you should know when you're looking at your angle, it should pertain and relate to the correct quadrant that you're in. One last thing. Sometimes you'll be asked for additional coordinates. So to find a coterminal angle, coterminal negative angle, subtract 2 pi. And finally, to find an angle in the opposite quadrant, that means r is negative, add or subtract pi. Okay? So let's go ahead and do another example real quick and just take a look at letter A. Okay? Let's take a look at this one real fast. Okay? So we've got root 3, that's my x. Here's my y. And I'm going to say, look, I'm going to go x steps to the right, and then I'm going to go down. So my x is root 3. My y is negative 1. And you might say, well, gosh, could I find r? You bet. You bet. You could say x squared plus y squared equals r squared. So I'm going to have root 3 square it plus negative 1 squared that equals r squared. So I'll have 3 plus 1 equals r squared. That's 4 equals r squared. And r equals, when you take a square root, notice I don't even have to do a plus minus because r has to be positive. R is going to be 2. Okay? Well, then what? Well, we've got to find our angle. And right now you can think, oh, is this theta? Be careful. That's a reference angle, right? That's what we're talking about up in number 3. The tangent of theta is going to be your y over x, and that's negative 1 over root 3. And guys, we've been thinking of that. It's as if you had negative 1/2 all over radical 3 over 2. And you could go from here and you could say, well, that would be like my y over x on the unit circle. And my y would be small, my x would be big. I know I'm in the 4th quadrant, so I'm going to draw over here in that 4th quadrant. I want my y to be small, and I want my x to be big. Well, where would that be? Y is small, x is big, guys. That, I hope we all are remembering, is going to be right here. That's with the pi over 6 reference angle, right? That's your pi over 6 reference angle. So you could say, I'm going to write negative pi over 6, negative pi over 6, or 11 pi over 6. So you could write either one of those. You really could write either one of those, okay? So when you'd say write your r comma theta, you're going to say your r is a 2. Look at that. You could have gone with this negative, right? By the way, you could have had the positive. That's like adding 2 pi right there. Kids might say, I just know where that is. That's 11 pi over 6. But what if the directions said, no, I want you to also tell me where the negative r's coordinates are going to happen? Well, if you've got that, guys, listen, what's going to happen is you're going to have to go backwards. You're going to go backwards here with the same reference angle. right? That's what a negative r is going to have. So that's going to be right here. You could say that's at 5 pi over 6, right? And by the way, that would have taken 11 pi over 6 minus a pi. You could have said, well, guess what else? You could go in a negative direction going this way. That would have been negative 7 pi over 6. That would have been subtracting pi from the 2 common negative pi over 6. So we're going to stop here, and we'll pick back up next class.